Hello, Math 95 students. Looking at section 9.6. Section 9.6 is about the quadratic formula. The quadratic formula is another way that we can solve quadratic equations besides factoring. So we've done factoring. We've done the square root method. And now we're going to learn the quadratic formula. Make that a little neater. Quadratic formula. All right. I would use factoring anytime it was possible. If it's possible to factor, I'm going to factor it myself because that's, to me, quicker and simpler. I would also do the square root method if it were possible. If factoring wasn't possible, then I would look to see if the square root method were possible, and if that was possible, I would go to that next. Because again, I think it's more complicated than factoring most of the time, but less complicated than the quadratic formula. But the quadratic formula, factoring and the square root method don't always work. The quadratic formula always works. So, how do you know when to use quadratic formula? Again, I would use quadratic formula only if the other two are not possible to do on that particular problem. So the square root method, let's look at that one more time. If you have an x squared term, okay, plus 3 equals 5, we can solve that with the square root method. If you have x plus 3 squared equals 5, we can solve either one of those with the square root method. So if there's just an x with a squared on it, or even an x in the parentheses with a squared on it, but there's no other x term in there, then you can use the square root method. But if we have something like this, x squared plus 3x plus 5 equals 0, or x squared plus 3x equals 5. If we have anything like that, where there's not only an x squared term, but also an x term as well. So there's an x to the second power and also an x to the first power somewhere in the problem, like x squared and x, then I can't use the square root method. Again, if I could factor it, I would, but sometimes we can't factor it, and so then I have to use the quadratic formula. What is the quadratic formula? The quadratic formula is this. The way to get your solutions for x is to use this formula: negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, I would encourage you to try to memorize that formula. Now, of course, you could put it on your notes page and you'll be able to use that on the test, and that's fine. But for your mathematical career, the quadratic formula is something that would be recommended to memorize because you would use it. It would be so useful. My wife, when she was taking a chemistry class, she had to remember the quadratic formula to solve problems in that college chemistry class. Here's how you can memorize it. You can sing a song. All right, there's multiple versions of this, but here's the one that I can sing to you and you can learn it. Sing this to yourself 5 or 10 times and you'll have it memorized. Negative b, plus or minus square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. Negative b, plus or minus square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. All right, again, sing that to yourself a few times, and it'll probably stick with you for the rest of your life. All right, let's look at an example of how this actually works. We're going to solve this example right here, this example 1. All right. So we actually already know how to solve that by factoring because this is factorable. Why do I know this is factorable? How do I know if it is factorable? Just ask yourself, are there two numbers that can multiply to get the last number here and add to get the middle number here? And there are, negative 4 and negative 2. So when that's the case, you can factor it, x minus 4, x minus 2. because negative 4 times negative 2 is 8. Negative 4 plus negative 2 is negative 6. And then I solve it. I set both of them equal to 0. I will get positive 4 there and positive 2 there. So my answers are 4 and 2. But we want to use the quadratic formula to get practice at it, because there will be many problems where you can't factor it. So let's practice it with this one. All right, let me erase this. Okay, so here's the problem written over again. Okay, the A and the B and the C are the coefficients, meaning the number in front of the variable, the coefficients of the x squared, the x, and the constant, respectively. So A is the coefficient of the x squared. What number is in front of the x squared? Well, it's an understood invisible 1 right there. So A is 1. B is the coefficient of the x. So what is the coefficient of the x? The number in front of the x is negative 6. And C is the constant, the number that doesn't have a variable. What is that one? That's 8. So now we have our A, our B, and our C. Now we just plug those numbers into that quadratic formula for the A, the B, and the C. So since B is negative 6, I've got negative B. That means it's negative 6. Right, negative b, b being negative 6, so negative 6, plus or minus the square root of b squared, so that's negative 6 squared, minus 4. A is 1, so times 1. C is 8, so times 8, all over 2 times A, and A is 1. So there are my numbers plugged into the quadratic formula. Now I just got to work it out. Simplify it as much as possible. So negative 6. What is negative 6? That's just positive 6, right? All right, plus or minus the square root of negative 6 squared, that's positive 36, minus 4 times 1 is 4, times 8 is 32, so minus 32, all over 2. So that's going to be 6 plus or minus the square root of 4 over 2. And the square root of 4 is what? It's just 2. So 6 plus or minus 2 over 2, which turns into 6 plus 2 over 2, and 6 minus 2 over 2, which becomes 6 plus 2 is 8 over 2. 6 minus 2 is 4 over 2. And then those reduce to my final answers of 4 and 2. So I get the same exact answers I got from factoring. Now that was more steps that way than it was for factoring, which is why I like to do factoring when I can, when it's possible. But now we've worked out an example, had a little bit of primary practice at the quadratic formula. Second example, 5x squared minus x equals 2. In order to do the quadratic formula correctly, it has to always be written that you have to put the equation in the format of ax squared plus bx plus c equals 0. It has to be in that order. The x squared first, then the x, then the constant, then the equal sign, and it has to be 0 on the other side of the equal sign for this to work. So how can I make this equation be like that? I need to move my 2 to the other side, right? So I'm going to move that 2 by subtracting 2 from both sides. So that gives me 5x squared minus x minus 2 equals 0. At this point, if it were me, I would see if I could factor it. I would say 5 times negative 2, right? The AC method, 5 times negative 2, that's negative 10. Can anything multiply to get negative 10 and add to get negative 1? No. That means I can't factor it. So now, and because it has not only an x squared term, but also an x term, that means that I also can't use the square root method. So I'm going to have to use the quadratic formula. What's my A, my B, and my C? My A is 5. My B is negative 1. And my C is negative 2. And I plug it into the quadratic formula. Negative B, so negative 1, plus or minus the square root of negative 1 squared minus 4 times negative, 4 times 5 times 2, so that's 4ac, all over 2 times 5, so that's 2a. So that's going to be 1. Negative 1 is 1 plus or minus the square root of 1 minus 4 times 5 is 20. 20 times 2 is 40. So minus, I'm sorry, I missed something here. What did I miss? Okay, look back. Look back at this number. What did I miss right there? It's a negative 2, and I put it as a positive 2. Let me change that to a negative 2. It's going to change things right here, right? Because negative 4 times 5 is negative 20, and then times negative 2 is positive 40. I've got two negatives multiplying right here, which makes this whole thing turn out to be a plus. So plus 40 over 10. So that's going to be 1 plus or minus the square root of 41 over 10. And because 41 can't be broken down at all, and I can't reduce anything, can't do any more simplifications, this is it. This is my answer. X is equal to that strange number. 1 plus or minus the square root of 41 over 10. It's still two answers. It's still, if you wanted to separate them, you could separate them as 1 plus the square root of 41 over 10, and the other answer is 1 minus the square root of 41 over 10. But so it's still two answers, but this way we can write it shorthand by saying 1 plus or minus the square root of 41 over 10. Example 3. Again, what's my first move going to be? I've got to get it in the right arrangement. I've got to move my 10x and my negative 3 over to the left side of the equal sign with that 2x squared. So I'm going to say 2x squared minus 10x plus 3 equals 0. Okay? 2 times 3 is 6. There's nothing that can multiply to get 6 and add to get negative 10, so it can't be factored. So I'm going to use the quadratic formula. So I've got negative 10 plus or minus the square root of negative 10 squared minus 4 times 2 times 3 all over 2 times 2. So that's going to be negative 10 is 10 plus or minus the square root of 100. Negative 4 times 2 is negative 8 times 3 is negative 24. So minus 24 all over 4. So that's 10 plus or minus the square root of 76 over 4. Now, I'm thinking the 76 may be able to simplify. So let me try to do that over here to the side. 76 breaks down to 2 times 38, and 38 breaks down to 2 times 19. So I've got a pair of 2's with an extra 19 left over. So I'm going to rewrite this as 10 plus or minus 2 square root 19 over 4. And now, each one of these terms, the 10, the 2 root 19, and the 4, can all divide by the same number. So I need to do that to reduce my answer, to put it in simplest terms. What will they all divide by? They will all divide by 2. So I'm going to divide them all by 2. And that's going to leave me with what answer? 5 plus or minus 1 root 19, or just root 19, over 2. And this is my final answer in its simplest terms. Example 6. Find the x-intercepts. Again, when we find x-intercepts, that means we're plugging in 0 for y. So in that spot right there, I'm just putting a 0. So 0 equals 6x squared plus 3x minus 2. And so there's my a, there's my b, there's my c. So negative b, so negative 3 plus or minus the square root of 3 squared minus 4 times 6 times negative 2 all over 2 times 6. So that's negative 3 plus or minus the square root of 9. Negative 4 times 6 is negative 24. Times negative 2 is positive 48. So 9 plus 48 all over 12. So that's going to be negative 3 plus or minus the square root of, let's see, 9 plus 48. Is that 57? 57 over 12. All right, let me see if 57 will break down. 2 won't go into it, obviously. Will 3 go into it? Let me just tell you a trick. If the digits of the number, any number, so in this case, the digits of this number are 5 and 7. If the digits add up to a number that's divisible by 3, then that whole number is divisible by 3. So since 5 plus 7 is 12, and 12 is divisible by 3, then 57 is divisible by 3. So this will break down to 3 and, so that's 1, 3 and 19, but 19 won't break down at all. So this number will not simplify under the radical. So that's all I can do. This is my answer. These are the values for x. Okay, next example. There's my A, my B, and my C. So it's going to be negative 5 plus or minus the square root of 5 squared minus 4 times negative 3 times negative 4 all over 2 times negative 3. So that's going to be negative 5 plus or minus the square root of 25. Now, negative 4 times negative 3 is positive 12. And then positive 12 times negative 4 is negative 48. Negative 48. Let me take you through that again. Negative 4 times negative 3 is positive 12. And then positive 12 times negative 4 is negative 48. So that's where that minus 48 came from. All over negative 6. So negative 5 plus or minus the square root of 25 minus 48 is negative 23 all over negative 6. Now, what do we do with the square root of a negative when a negative is underneath the radical? When a negative is underneath the radical, I need to treat it like it's a positive number and just put an I with it. So it's negative 5 plus or minus. 23 won't break down, so I'm just going to bring an I outside of it and put it in front of the radical and make it become a positive 23 under there over negative 6. Now, this is going to be aggravating. We would be finished, except on the bottom here we have a negative number. That's aggravating because we don't want to have, it's kind of strange to have a plus or minus and then have a negative under it. There's another simplification we can make. And what we're going to do to make all that different is we're going to divide everything. One second here. Get me a different. So divide everything by negative 1. Okay, so that makes me have positive 5. And if I'm dividing this term by negative 1, then that plus is going to become minus, and that minus is going to become a plus. But so it's going to, instead of being plus or minus, it's going to be minus plus. But minus plus is the same thing as plus or minus. You're just adding something or subtracting something. So I'm going to do both anyway, plus or minus. I root 23 over, this is going to be now positive 6. So here are my answers to that one. One thing we could do to avoid that confusing part at the end is we can avoid that by making sure that our A term in this original problem is not negative. You can make it where that negative 3 is not a negative 3 but a positive 3 by moving every single term over to the right hand side. So when I do that, that becomes positive 3x squared minus 5x plus 4 equals 0. Or I could put equals 0 over here. It doesn't really matter. So if we do that at the beginning, and that was just again to ensure that this, that's strange. I don't know why it marked there. Very strange. Anyway, to make sure that that first term is not negative. Okay. All right. So this next part, we're not having to solve an equation in this next part. We're learning the definition of a word, this word discriminant. What does the word discriminant remind you of? Probably it reminds you of the word discriminate. And that's exactly what a discriminant does. It discriminates. What does discriminate actually mean? It means to distinguish the difference between things. It means to distinguish the difference between things that are different. And so to do that is not inherently an evil thing to do, right? So like when you go to the supermarket, you will discriminate when picking out peaches. You're going to get the peaches that are ripe, not the ones that are rotten. You're distinguishing the difference. If you are hiring someone to babysit your children, you're going to discriminate against those with a history of child abuse, right? So to discriminate is not an inherently evil thing to do. It's just a matter of how you discriminate. For what reasons are you discriminating, right? So if we discriminate just based on skin color, obviously that would be wrong. So, but the discriminant, it distinguishes the difference mathematically between types of solutions for a quadratic equation. So if you do the discriminant, if you figure out what the discriminant is, you can tell what kind of solutions there are to the quadratic equation you're dealing with. So the discriminant is b squared minus 4ac. That is the discriminant. It's the part that was under the radical. It's the part that was under the radical. So just the b squared minus 4ac part. The part that was under the radical for the quadratic formula. That is the discriminant for a quadratic equation. You just do the b squared minus 4ac. That's it. And if b squared minus 4ac is greater than 0, so here's where I am. If b squared minus 4ac is greater than 0, in other words, if b squared minus 4ac gives you a positive number, then there are two real number solutions. Two real solutions. All right. If b squared minus 4ac is equal to 0, if you get 0 under the radical, if b squared minus 4ac, if you get 0 from that, then there is one real solution. Okay? And if b squared minus 4ac is less than 0, in other words, if it's negative, then you don't get two real solutions. You don't get one real solution. You get no real solutions. In other words, you get two imaginary solutions. Two imaginary solutions. So graphically, here's what we're talking about. We're talking about if b squared minus 4ac is positive, you get two real solutions. That means you get something like this. You get two solutions. If b squared minus 4ac is equal to 0, you get one real solution. That would be something like this, where it hits the x-axis in just one spot. If b squared minus 4ac is less than 0, it means there's no real solution. That means you have a situation like this, where the parabola never intersects the x-axis. So let's apply that discriminant to this problem. 2x squared minus 3x plus 5 equals 0. So we're just doing b squared minus 4ac. B squared minus 4ac is all we're doing, where the b is negative 3, the a is 2, and the c is 5. So negative 3 squared minus 4 times 2 times 5. So that's 9 minus 4 times 2 is 8. 8 times 5 is 40. So that's going to be 9 minus 40 is negative 31. Well, that's less than 0. That's a negative number under the radical. That means we got what? We have no real solution, or we could say 2 imaginary solutions. 2 imaginary solutions. So we don't even have to solve the thing. We just got to tell what kind of solutions we got. All right, this problem says for this function, this quadratic function, find the number of points that lie on the graph of f at the indicated height. So how many points are on this graph at this height? That means I'm plugging 5 in for y, in other words, f of x. So I've got 5 equals x squared minus 6x plus 12. Now it doesn't actually ask me to find the values of x to make that true, or the values of x at that indicated height. It just tells me, to determine how many points, the number of points, which means all I have to do is use the discriminant. So to use the discriminant, I do have to move that 5 over. So I've got to subtract 5 from both sides. So x squared minus 6x plus 7. That's what gets it into the format that we need. All right, so that's going to be b squared negative 6 squared minus 4 times 1 times 7. So it's 36 minus 28. All right, that's going to be 8. That's greater than 0, so we have 2 points at that height. 2 real points at that height. Now, the next part, I'm doing the same thing, but I'm plugging 3 instead of 5 in. So 3 equals x squared minus 6x plus 12. So move the 3 over, and we get x squared minus 6x plus 9. So now I've got negative 6 squared minus 4 times 1 times 9, 36 minus 36. That's equal to 0. So we have 1 point, 1 real point at that height. And lastly, I have to plug 1 in. So 1 equals x squared minus 6x plus 12. Move the 1 over. Plus, what's the 12 minus 1? 11. So I've got I've got negative 6 squared minus 4 times 1 times 11. So that's 36 minus 44. That's negative 6. So that's less than 0. So that means we have no real points. None or no points at that height. There might be 2 imaginary points, but they're not 2 real points on the XY plane. It won't hit that height at all on the XY plane. Okay, example 10 here says decide which method to use. Look at examples 1, 2, and 3 here, and we're trying to determine which method should we use. We now know 3 methods: factoring, square root method, and quadratic formula. For the first one, all right, pause it and you try. See what you can do with all 3 of them. See how you would want to solve it. All right, for the first one, I would see if it can factor anything that multiplies to get negative 54 and adds to get negative 3. Yes. Negative 9 and positive 6. So number 1, I would solve by factoring. Number 2, I would solve using the square root method because it's set up for it. It's got an x with a squared on it, but no x term. That means I can get that x by itself using the square root method. Number 3, I'm not sure which method I would use. I would have to FOIL this out and then distribute that and combine my like terms to decide. That's going to give me x squared minus 2x plus 3x. So that's going to be plus x when I add those like terms together. Minus 6 equals 2x plus 2. Move my 2x over and my 2 over. That's going to give me x squared minus x minus 8. Anything that multiplies to get negative 8 and adds to get negative 1, no, there's not. So I'm going to have to use what? The quadratic formula. I'm not going to do it because I've already showed you plenty of examples of how to do that, but that's kind of the general way you think about what should I do? Which method should I use? Now, if you had said, well, I'm going to use the quadratic formula on number 1, that's fine, because it still would have got you the right answer as long as you can do the quadratic formula correctly. But factoring just would have been a little easier and quicker. So anyway, that finishes us up for all the examples in 9.6. Good luck on that assignment. We will stop there and do 9.3, 9.4, and 9.6 as a single test, a pretty short test. So you'll see a practice test on that. Hopefully you're getting the hang of all this. Anyway, good luck to you. Appreciate it.